Do you believe that life once returned to the dead body of a man in Palestine? Do you believe that blood flowed again in his veins? And do you believe that as his spirit rose from the dead, it left behind an image of the man on the cloth that had covered his tortured body? If you so believe, then you will not question whose face is now before you. For this is the face on the holy shroud of Turin. The image of the man on the cloth is flanked by marks of time and neglect, scorched by fire and patched by the faithful, doused and stained by water. On the left half of its 14-foot length is the faint image of the front of a man, and, with heads together in the middle, the right half shows his back. But who is he? Well, he's left a trail of clues. Start with a pathologist trained to read the signs of death.
Treating it as a photograph and looking at the front of the body, one can see that it is a male, approximately 5 foot 6 inches in height, a face which has the features of a man between 35 and 40. He has a mustache, bearded, long hair going bald. There are trickles of blood, consistent with a cap that went over the whole of the top of the head, causing small scratches. With regard to the chest area, one can see that there is evidence of blood staining, which would be quite consistent with a wound into the side of the chest between the 5th and 6th ribs. Here, the wrists, one sees the mark of extensive blood staining, and then the sort of stairway pattern of the bleeding on the forearms. There is ample evidence to suggest that the picture depicts one who died, in my estimation, on the cross, and is therefore a crucifixion victim.
If that victim was who you're thinking it was, then the shroud is rightfully held by the church in respectful isolation. Hidden from the light of day, wound round a velvet-covered staff, wrapped in red silk, and locked thrice behind iron bars in Turin Cathedral, the shroud has been revered for 6 centuries. Before that, from the day the angels watched a freshly crucified body being covered, there's a 1300-year gap in the history of the shroud. Then, in 1357, a cloth popped up in the hands of a small-time French nobleman called Geoffrey de Charnay. By 1450, times were hard for the de Charnays, so it was sold for a couple of castles to the Duke of Savoy. Under his close care, it caught fire in 1532, hence the scorches and patches we see today. Despite that, it was just the sort of thing to make the Savoy family famous and pull in the visitors. Of course, you get more kudos if you give it to the church, so in 1578, off it went to Turin Cathedral for safekeeping. Since then, it's been out in public only on very special occasions, revered, praised, touched and copied by every pilgrim who could get to it. The last time was in 1978. But the church makes no claim of miracles. It well knows that in the 14th century there was a lot of money in the relic manufacturing industry. Put together all the true crosses and you could build a cathedral. How many crowns of thorns were there? Or tunics? Or holy nails? There was even St. Peter's arm and the jawbone of St. Anthony. In fact, a 14th century bishop passed a letter to his pope claiming he knew the man who painted the shroud. A forger's art or a relic of Christ? What is the image and how did it get there? Well, in 1978, an American-sized team of scientists came to Turin to test the shroud. Under watchful eyes, they poked it, cut off its backing, pulled it and tugged it. They photographed it through microscopes, with X-ray, ultraviolet, thermographically, with infrared and even backlight. They stuck sticky tape on its surface to remove the tiniest of samples, all they were allowed, for chemical analysis. And after 4 years, what's their conclusion?
From my analysis, I think there was a body shape under the shroud when the image was formed.
I am certain that the shroud was painted during the Middle Ages by an artist. no way whatsoever is this what could be termed a painting.
If it's supposed to have been made by the hand of man, the scientific evidence is overwhelmingly against it. But what does that leave? We just don't know.
What it does leave is a faint, elusive image, so faint that you only see it clearly with high-contrast photography like this. The closer you get, the less clearly you see it. But when it was first photographed, the negative revealed a remarkable sight. The full serenity and majesty of the man it represents. Shroud believers asked, how could a medieval artist have painted such a picture 500 years before a negative had even been invented? The features are so precise that a modern artist has been able to create a three-dimensional face. Just think who you may be looking at. Scientifically, 3D analysis has now become high-technology shroud research.
I'm sitting in front of a VP8 image analyzer, which converts shades of light and dark into levels of vertical relief. To show how it works, consider the image of my face. My face you see with reflected light. The amount of light that's reflected is converted into vertical relief. And we have a three-dimensional image of my face, which of course appears highly distorted.
Turning the video camera to a photographer's grayscale, you can see how the VP8 works. From black through all shades of gray to white, the VP8 gives each one a different vertical height, so a grayscale looks like a staircase. Now look at the shroud. For at least one man, it was almost a spiritual experience.
When I first saw this image on the VP8 image analyzer, I think I'd have to say that I was amazed. If this was the true burial cloth of Jesus, perhaps maybe I was looking at the body shape of Jesus when he was wrapped in the tomb.
If that doesn't surprise you, try a medieval painting. The painter gets his 3D illusion by making highlights white and shadows black. But when the VP8 converts them to height, the 3D effect is totally unreal. Look at the black moustache. It's really the same height as the white sparkle on the cheek, but it doesn't look it. You get the same result for any painting or any photograph, a three-dimensional disaster. But Jackson called in the police to do another test. Police artists are trained to compile pictures using shades of light and dark. Jackson got them to draw a shroud-like bust, but only in terms of shade equals height. There was a lot of cursing and swearing, but the result was quite interesting. What do you think? Almost as good as the shroud? Not, according to Jackson. That suggests the shroud is not from the hand of man. But if this is just the function of a sophisticated computer, then we need to know more about the medieval artist's knowledge of medicine.
Looking at the skeletal hand and the wrist, if one were to depict a nail going through the palm of the hand, as was done by old artists, when the body is suspended on those nails, it would tear out. Therefore, the nail would have to go through the wrists, in which it couldn't possibly tear out. And this is what is depicted on the shroud, in that the blood originates in the wrist. From a medical point of view, when one places the nail through the center of the wrist, one could damage the median nerve. The median nerve controls the muscles of the thumb, and when damaged, it will cause paralysis, and the thumb will fall in that position. And this may be one of the reasons why one does not see the thumb in the image on the shroud.
At NASA's Jet Propulsion Laboratory, the very best image enhancement techniques have been applied to the shroud. They increased the contrast for the chest area, but found no sign of an entry to the wound. And the same on the wrists. No nail hole. The X-ray results from Turin showed nothing but the water stains. Infrared showed nothing. Thermographic analysis, a sort of splodge. Ultraviolet photography was more hopeful and brought the first real scientific clue. The scourge marks showed up in more detail. The cloth fluoresced slightly while the image didn't at all. But, and here's the clue, the scorch marks fluoresced a bright orangey brown, so the image wasn't a scorch. Sample analysis was next. This is the ultimate in high-technology chemistry, Raman laser spectroscopy. It is sensitive enough to identify traces of the plastic bag used to carry the samples. But on the shroud, it found experimental scatter. You and I call that nothing. But one test did produce results, X-ray fluorescence. It revealed large quantities of calcium throughout the cloth, and a scan of points across the image showed iron. The levels were much the same, but on the blood markings, the level of iron was high, and real blood contains iron. But one man has another explanation. Walter McCrone's business is exposing fakes, and he does it with the aid of his eyes and a microscope. He was first with the shroud samples. He saw the tiny yellow fibers that make up the image, but he also saw little particles on them. Compare the fiber backlit and toplit. The particles are bright red. He also found little clumps of red particles, particularly in the bloodstain areas, which appear unnaturally red for 2,000-year-old blood. He identified them as iron oxide pigment, with occasional specks of madder rose, both favorites of medieval artists. Another test stained parts of the blood fibers blue. McCrone argues that shows the presence of a protein medium to bind the paint pigment.
When I examine any of the body or blood image areas, I see a red material, which I've identified as an artist's effort, the pigments and medium. If that were removed from the shroud, there would be no visible image.
Take a dash of vermilion, the artist's favorite iron oxide. Drop it into pure water. Add a drip of protein to bind it. Shake well, and Walter McCrone will paint you a shroud. He may not be the best artist in the world, but he's convinced he has truth on his side. Certainly, the result's interesting.
Not too bad for the Middle Ages.
But there's one crucial snag. McCrone's paint penetrates the cloth, whereas the real shroud image is only on the surface. Al Adler and John Heller are forensic chemists, and their task was to work out the chemistry, cutting the tiny fibers off the sticky tape and testing them with reagents, all done through the microscope. They did over 1,000 tests. They confirmed the presence of that calcium in the cloth, also iron and protein in the bloodstain areas. But on the image, the result was eye strain.
The image of the man is composed of nothing but dehydrated oxidized cellulose.
That's linen yellowed with age.
There has been nothing added in the way of any paint, pigment, stain, or colored material of any type.
But they did reinterpret McCrone's red particles. Hydrazine dissolves dried blood. Add formic acid. And under ultraviolet light, the whole lot fluoresces brightly.
All right, John, I'm going to add the hydrazine.
They tried the test on shroud blood.
It's giving a positive hemochromogen test, John.
Okay, so that is blood.
There's absolutely no doubt in my mind. This is blood. B-L-U-D, blood.
Sadly, it doesn't prove it's the blood of Christ. After all, you can paint with blood.
The what actually has been answered in terms of the physics, the chemistry, and the forensics. We actually know the chemical structure of the image, we know its physical characteristics, and we know this forensically correct. The amazing thing, however, is that we still have no simple explanation for the how. That is, how that correct physics, chemistry, and forensics all came together in the same place on that piece of cloth. We still do not have a simple explanation for it.
So this faint image is just the old, yellow, degraded cellulose fibers of a linen cloth. but it has withstood the blitz of 20th century science with its real secret intact. No one knows how those fibers were degraded. In the aid of the science of miracles, Larry Dutremble is working up a healthy sweat. Vern Miller was the Shroud's scientific photographer, and he's trying to perfect a recipe. Spices, myrrh, and a touch of embalming oil of olives. Mix well, and you have just the right kind of goop.
You don't have to worry, Larry. This is not going to hurt you a bit.
The idea is that of Sam Pellicore. He thinks that where the body contacted the cloth, the sweat reacted with all the embalming ointment to degrade the fibers of the linen. The experiment stops short of crucifixion, but otherwise Larry gets the full treatment. The cloth has to make a good contact with the body, but the sweat must not soak through, only the surface must degrade. A few minutes is enough.
All right, let's take it off.
A little heat adds some artificial age, about 1 hour for every 1,000 years. The result is chemically very good, and under the microscope it's just like the real shroud, only on the surface.
You can see the position of the eye sockets, and you can see the eyebrow and the nose and the lips and the beard. Otherwise, it is a very unrecognizable image. The major problem with the contact hypothesis type mechanism for making an image is that you will contact the high points when you put a cloth on a face, and you won't have contact in the hollows.
If so, then why does the Turin shroud show the low points as well?
In fact, if you look at the shroud, you see that there are bruises on the cheek and the eye, so that the relief that you're dealing with in trying to reproduce the shroud is not the relief of a normal face, but is the relief of, say, a beaten face. In this case, I think we might have to take Larry out, beat up his face a little bit, and try it again.
I think it's time to leave.
Still a long way from a satisfactory explanation. QED decided to try making its own shroud.
I think a medieval artist was capable of painting the shroud. The only problem is there's no actual pigment on the image.
We took an artist to a textile research institute and left them to think out a medieval answer.
Our problem was to find something that would reproduce this, leaving no traces, because we find no evidence of materials like protein or pigments of any kind, of metal ions, with the possible exception of some calcium, which is there in quite large quantities. We tried several materials that we know from past experience degrade cellulose in this way, and in the end we settled for alum, a material widely used by artists in medieval times.
Having settled on alum to degrade the cloth, Susan had to find a pigment so she could see what she was painting. She chose Brazil wood, often used with alum and so popular in the Middle Ages that they even named a country after it. You mix it with water, boil it up, filter out the lumps, and then evaporate the fluid to get a perfect pigment. For a canvas, she used modern linen cloth that was specially woven to be like the real shroud. That was sized with gum arabic, which contains calcium. And remember, the shroud contains calcium. Finally, a mixture of more gum arabic and alum was the medium to take the Brazil wood pigment. The rest was up to Susan's artistic skill. There's one very obvious question. If an artist was trying to paint the image left by a body under a cloth shroud, why do it as a negative image?
I think he naturally put more paint on the points that were going to be nearest to the cloth, like the eyebrows. And he'd automatically end up with a negative image.
Okay, I hear you say. Let's take a look. Impressive? Painting in negative. The final bloody touches add a bit of color. and the finished product goes off for a bit of aging. We know that in the 15th century, the shroud was washed in order, they believed, to test its authenticity. They probably used soda ash to get rid of those stubborn stains like alum and Brazil wood. That's what's called putting your reputation on the line. Well, there's the result. Looks good at a distance, and the closer you get, the less you see, just like the real shroud. Tests showed that chemically everything was washed away except calcium and iron, and under the microscope the effect is strictly on the surface. It's all very like the real shroud. But the 3D test still has to be passed. Viewed from this side, the real shroud is a bit better than Susan's painting. But turn the other cheek and there's very little difference. All in all, it looks as though our fake is extraordinarily like the real thing. But if you reject all these ways of making the shroud, then you're left with just one other possibility: a miracle.
I don't think a scientist is able to add anything to the knowledge of miracles. He's in the same realms as everybody else. If you believe in miracles, you can believe in anything.
Teddy Hall is to do the ultimate test: radiocarbon dating. And for that, miracles are irrelevant.
Well, of course, carbon-14 won't tell us anything about that side of it at all. All that radiocarbon dating does is to tell us when it was made, not how it was made.
Carbon is the chemical base of life, constantly being produced in the body until death. So the flax plant that made the linen of the shroud gave each thread 3 kinds of carbon: carbon-12 and carbon-13, which are both stable, and carbon-14, which is radioactive and decays. We know how fast it decays, and we know the proportions of the different carbons in living flax. So by counting how much is now left, the shroud can be dated. The test must be confirmed by several labs, and just to be sure they can't cheat, each will get a sample of the real shroud fibres, secretly identified, along with samples from other similar cloth. The fibres get washed in acid to leave pure cellulose. This brand new method of carbon dating only needs about 20 milligrams, which they promptly burn in a vacuum. The gas that comes off is carbon dioxide, and that is drawn through the vacuum and purified and refined by alternate heating and cooling until its carbon is deposited onto a fine wire in the form of, you might say, holy graphite. This tiny sample of carbon, by now only 5 or 10 milligrams, is placed in the accelerator and bombarded by an electron beam. Charged atomic particles of graphite are released and move to a magnetic field which deflects only pure carbon atoms. They accelerate across 1,000,000 volts to a second magnet, which deflects in turn the carbon-12, carbon-13, and carbon-14 particles. They pass down to a detector, and so the 3 types of carbon atoms are counted one by one. The computer calculates the proportion of the 3 carbons, how much carbon-14 has decayed, and so how old it is. The result will be accurate to 100 years. The sample will be fired through this accelerator. It will be measured using the most fundamental laws of science. A few atoms of matter will decide a question that has vexed men of learning and of faith for over 600 years. And that process will take a mere 15 minutes. The labs are preparing for the test, and the world awaits the Church's permission to do it. One day soon, we'll know the age of the shroud. Of course, that won't tell us who made it or whose image is on it, but the scientific finger will point firmly in one direction, either at the holiest of relics or at a worthless fake with no place in heaven.